Hi everybody, my name is Oscar Mariño and I'm a PhD student at the School of Aeronautics in UPM, Universidad Politécnica de Madrid, in Spain. I am ESR 12 of the Zephyr project, towards a more efficient exploitation of onshore and urban wind energy resources. Wind turbines are an important part of the transition to renewable energies. As more space is used to place wind turbines, simple and open flat areas are no longer easily available. This is the reason why in the near future, onshore wind turbines will be placed in more complex terrain, including mountain landscape and urban landscape using buildings. This makes that the incoming wind for the turbine is not uniform and has small variation, or turbulence. This changes the performance of the wind turbine itself, which means that the energy produced varies, and also the noise that is produced by the wind turbine. When the wind turbine is being designed, a computational software that can include this is needed, having a lot of precision for these complex physics. My research is focused on the development of such tools, using advanced numerical methods called high order. We are using a code developed at UPM that helps to assess different options and models for this complex physics of noise and wind turbines' energy production. The main challenge of my research is that for each feature that I have developed, I need to test it and compare with reference values, so that I was both a developer and a user of the software, and it can take a lot of time. The outcomes of my research can be divided into categories. The first one is related to airfoil simulation. The airfoil is the geometry of a blade section of a wind turbine, they code in this direction, and can have this kind of shape. In this, I simulated the evolution in time of the flow around the airfoil. Here, I studied different parameters and models to take into account the turbulent behavior of the flow. This is important because capturing the small variations of the flow at the surface is what defines the good prediction of the noise that is generated, and that later on is propagated to the surroundings. In the picture, you can see the visualization of the sound waves coming from the rear end of the airfoil. The second category is related to the simulation of wind turbines itself. Here I use a mathematical model that follows the position of the blade in time and add a corresponding force to the flow. This is useful to simulate the wake of the wind turbine and the interaction with not uniform flows as are the ones presented in complex terrains.